and I will post back all the recording session in the e-learning, so you can have a look. Can refer after the offline. Okay, before we continue, do you have anything to ask? Do you have anything to discuss? If you don't have anything, we shall continue. Okay. Okay, this is to show you how important is the to identify, to select a suitable data for your development of embedded system, especially when you use develop your firmware. Okay. This is one examples of when you use one single picture with the resolution of 1920 multiplied by 1080. When you use the high precision integer, integer long, it is a 64-bit. You require for a single data, for a single pixel, for example, you require 64-bit. If you have this size of, picture, then you are required to have about 50 megabytes single picture. So it's important to know that for embedded firmware that you want to develop, you have a limited resources, especially the memory. Okay. And we also can imagine this is to become exaggerate, to become more complicated when you have a hyperspectral image. Okay, this hyperspectral image actually normally being used in the satellite monitoring. Okay, you have a lot band of data. This is only for 512 multiplied by 512, where you have 224 other image. So for a single image, if you use an integer 32-bit, you require 235 megabytes of picture. So you can imagine if you are going to use it for the embedded system, for integer alone, you require 32-bit. So you, for a single picture, you need to use a space of 235 megabytes. For long, 64-bit, 470 megabyte for a single picture. So if you know details about your data, you may use smaller data type for a hyperspectral image, which capture in 16-bit ADC resolution. You can use 16-bit integer, which is going to save a lot of memory for a single picture. Okay.
Professor, why choose 512 and 224?
Sorry?
Why choose 512 and 224?
Okay, 512 is a single picture. And this 224 is a different band. Okay, if you see, this is a stack a lot of band up to 224. A single picture is only 512, 512. Okay, if you have different band, okay, different capture, for example, you want to monitor the temperature, the humidity, so you have a lot numbers of band. So this is just for example. If you are going to use this kind of picture, 512, 512 plus 224 band, so you require 234 megabyte for a single picture. A single picture which contain all the bands. And this is for example only. Okay, and this is being used in satellite. Okay, it's being used in satellite. So if you are capturing using ADC, you convert to digital using 16-bit resolution. Okay, and you use a 16-bit integer in your processing in your embedded system, then you are going to save a lot. Okay, it's going to be less than 235, maybe about more, less than half. Okay. Does it answer your question?
Yes, thank you.
This is just for examples. How important to select a suitable data type for your application in your embedded system. Sometimes maybe you don't require a high resolution of image to apply in your application. You don't require it, especially when you, okay, let's say face recognition. You don't have, I mean, you don't need a face recognition for security purposes. Maybe you require only few centimeter from your system, so you don't need high resolution. You can, I mean, enough for the application. Or if you use for the number plate application, number plate to recognize the plate numbers, maybe you don't need a color, you don't need RGB. Okay, you just need code. Okay, black and white only. So it is suitable for that kind of application. It's less data type. Okay. This is data type. This is normal data type in the C or C++. We have character which use 1 byte size. You want to identify one character, you only require 1 byte. Unsigned character also 1 byte. Short, 2 byte. Unsigned short also 2 byte. Integer require 4 byte. Okay, unsigned register 4 byte. Long 8 byte. 8 byte. 8 byte, it means that 8 multiplied by 8, 64 bit. 8 byte, this is mentioned in byte. But the bit number is multiplied by bit. Each byte is 1, each byte is 8 bit. Also, this is the integer which supported and recommended by Vivado. Okay, for your information, I don't have experience with Vivado, okay, daily. So I'm going to use Microsoft Visual in all my examples, and I'm using the programming. I'm going to use this Microsoft Visual and Microsoft Studio, and I'm using the version 10. I think we have up to version 22. I think 22 also I have. I'm not using it because of my laptop. I have I mean, low performance kind of laptop. Hopefully tomorrow they will bring to me a new desktop. I'm able to use a desktop. Thing. Okay, so in Bilbado, later on, maybe if you want to use the one that I'm using, I will put in the e-learning. You can download it and install it in your PC. Or you might use the more update version. I don't mind. It's about the same actually. And in Vivado actually also they have kind of integer where you can select either you want to use 8, 16, 32 or 34 or 64 bit of integer data type. Okay. Okay. And then we are going to look at memory. This is one of the requirement to develop embedded system. Okay, first you need to have a microprocessor or microcontroller. Then you need to have memory and I/O. Then you have a system. So now we look at memory. Why we need to know about memory? There are 3 types of memory. We call it stack, heap, and static. Okay. Either for C or C++, we can generalize that we have 3 different pools of memory. The first one is static. Okay, when you use in your programming as a global variable storage, it considered as a permanent throughout the run of the program. When you run a program, global variable will be fixed in the memory. It will use that particular location and then it will be always be used the location even when you run the program throughout the entire program. And then we have a stack. Stack is considered as a local variable storage, and normally it is automatic. It is being set by the operating system, and it is continuous in location inside the memory. It is. Okay, I will, while we are discussing later in timing, then I will mention about the stack. And also we automatic mean it being created, and after it came out from the subroutine, it will be, you can use that particular for other purposes. Okay, that's what we mean by stack. And it is crucial. Okay, every system requires stack because every time when you go to the subroutine, you are need a space for stack, and stack normally be defined the size and the location. Okay, in programming for because we are using the high level language, low level language, and we can define exactly where do you want how much of the stack. When you go to the subroutine, when you enter the interrupt, you require a space. Okay, sometimes I think the last kind of Microsoft operating system. When you have a stack overflow, your screen become blue. They call it blue screen. Okay, that is because of the stack overflow. Means that you don't have enough space to run certain call function. Okay? And it is automatically being assigned by the operating system, and it being assigned continuous in memory location. And then we have heap. Heap is a dynamic storage, dynamic memory allocation. Normally, it requires a large space, large chunk of memory, and it's not contiguous, not continuous in location. Okay, it is in contiguous order. Okay, normally outside of the main program, we call it as a global variable. Okay, static variable inside the main program. If you put static, so it's going to be as static. You use a static application, static memory location, or you put outside the main program. We consider it as a global variable. It is also static. And then stack is inside the main or a function. Okay? It is considered as a local variable. Whenever you go to the function, it will create, assign the variable. Okay? So it requires a location, a certain space of location. Okay, and it is last in, first out. Okay, if you, because in high level language, it's already being automatically being taken over by the operating system. By C or C++, then you don't bother about it. But in physically, if you are going to put it by assembly language, this is the way of put the stack. Use the stack. Okay, last in, first out. You push the last variable that being pushed is the one that going out first. Okay. When the function ended, all the variables are deleted, means that you are remove all the location. Even if you access that location, it's not valid. It's not valid. Okay. Okay, managed by operating system automatically, because we are using the high level language. Okay, if you use low level language, then you need to manage it. And as I mentioned to you, operating system, I think almost all the operating system, they are using low level language, using assembly language to code it. Okay, we are going to look detail during the operating system later on. Okay, after second part of our lecture. Okay, it has limit, as I mentioned. Normally, you will declare how much stack that you want to use. Okay. If you over the limit, it will cause the stack overflow error. Okay, last time in the Windows, they call it as a blue screen error. That is one of the error because of the overflow stack overflow. And then heap explicitly allocate by malloc. You can put it in the programming. In C, you use malloc. And in C++, we use new operator. And you can reallocate it, make it free, okay, by using free function and delete operator. Free is in the C and delete operator is in the C++. Okay. And this dynamic memory allocation, you require to use a pointer. Okay, you need to use pointer. That's why we are going to study, discuss about pointer. Okay, this is an example. Static, probably we have a small portion of memory space being used. Okay, compared to stack, because stack, well, every time when you enter the function, you are using the stack. It's going to be quite large. And then heap and the stack, as we know, it is a contiguous. It being located in contiguous order, where the last variable in will be the first going out. And the last one we discussed about heap. Okay, heap. Okay. It depends on how you declare it, how you allocate the variables, okay, and it is not contiguous. Okay. It can be anywhere. It's scattered in the memory. Okay, and it's considered a large, normally a huge space of memory. Okay, it depends on what kind of data type you use to be okay. Okay.
Excuse me, Prof. May I know what is contiguous?
Means that it is in order of management. Okay, you have example, this is location number 1, the next location is number 2, 3, and so on. So it means contiguous. In heap, this is number 1, number 2. Suddenly this is number 16, number 18. It's not contiguous order. It's not in increment by 1. That's what we mean by contiguous. Increment or decrement by 1.
Okay, thank you.
Okay. Stack is contiguous, mean that if the last one is 100, the next last one is 99, and then 98, and so on. But not in heap. Heap can be scattered in the memory. If this one, the first one start with 1 until 10, and the second one can be start from 100 to 200, and so on. So it's scattered. It's not in contiguous order. Okay, that's what we mean by contiguous order. Okay. Okay, now we go for the programming. This is, I think all of you have the experience of using the C programming or C++. Do any one of you didn't have experience with C? Okay, so I assume all of you have experience with C, but I think most of the undergraduate are not cover what we are going to discuss today. So I'm going to refresh back, okay, about the programming. Okay. So in programming, we have headers. Headers is where the library file is being placed. Okay. In certain function, it requires certain library files. A header, we call it header. And it is the name of the file. Normally we got H. Okay, and then we have a main function. Okay, this is necessary. Okay, in every code application that you need to have a main function. And this main function is up to you to decide what kind of main function that you have. For example, by default in, okay, let me share you. Let me share you the visual Visual Studio. Okay, this is a Visual Studio. This is the one that I'm going to use. Okay, when you open a new project, okay, when you create a new project, okay, normally we are going to create a Win32 console application.
Professor, are you sharing your screen?
Oh, sorry. Share. Okay, can you see it now? Okay, this is a Visual Studio form. Okay, I'm using this one. Okay, using this to make a coding. Okay, when you create a project, for examples, you you need to put a file name. You just put uh, okay, it is a console application. Okay, then we finish. Okay, if you look here by default, and you create the for Visual C, the main program will be named as such. So when it has a return value, since it is an integer, so you need to put return value. Okay, and then it has the argument. Well, here this is argument. The first argument is integer, and the second one is a character pointer. And this is by default. And you have the new project in the Visual C. Okay, it's going to be different with other kind of other kind IDE that you use. It is so main function in this case is void. So void means that you don't have any return value. And then this is the other function. Okay, you can have the other function on top of the main function. there will be advantage and disadvantage of this. Okay? Compare on what kind of firmware that you want to use, that you are going to develop. Okay, these we consider as local variables. Okay, these local variables, it is going to be in memory. What kind, guys? Anyone? What kind of memory that is going to be used?
Stack.
Yes. Okay. Or local variable is going to be stack. And then this is a global variables. Global is going to be
Heap.
okay. So it's going to be fixed. It's going to be fixed throughout the running of the program. So that's why if you're going to save the space, it is good to use the local or use the stack or use the dynamic memory allocation, especially in the embedded system, because you are saving the resources. Okay. And then this is a calling function. In the main program, you call the function of the other function. In here, it is add function. Call it in the main program. Okay, where we have the argument in the function, where this argument you pass from the variable inside the main programming. A and B you pass to the function add as integer y and integer z. This argument should be the same as in the main program. The same data type. Okay, for here, if you look, add A, B, A and B. A is integer, B also integer. The value of A is 4, and value of 5. Then it's going to pass to the other function where declare the argument is declared as y and z. So y is become 4, z become 5. Okay, so the other way around, okay, this is one way to create firmware. We have another way where you declare a function, you declare a function declaration. You need to put a declaration of the function in the beginning. Actually, both of these are the same. Okay, you need to declare the function. If you are going to put the main program in the beginning. After, if you put the other function below the main program, so you need to make a function declaration. Okay, there are certain advantages and disadvantages. It is good to have it, but you need more type. I mean, more line to type. In this, you don't need to declare it, so you have less declaration function, but it is much more easier. Okay, in the second one, where the main function actually in the beginning of the program, if you have maybe few up to 50 or less than 100, so it's quite tedious to find the main program. Okay, if it at the bottom of the program, so you can use both of it. Okay. For me, I prefer the second one. If I'm going to write a long code, so the second one is much better because your main program is the beginning of the program, your code. Okay. So far, okay, this is where in the examples you have the main program void and you don't have any argument in the main program. Actually, as I mentioned, most of the C++ programming, what we call it, you have a lot of programming, Visual Studio, GNU, and a lot of others. Okay, this is also similar to integer void or integer main. You don't put anything in the argument, but it must return an integer value. So at the end of it, you put return 0. The effect is the same. Okay. Most of the platform for C++, as I mentioned, the one that I'm using is Visual Studio. You can use Vivado, you can use GNU. There are a lot of other platforms. So most of it actually have a return value and also have the argument inside it. Okay. And this argument normally it has the first one is the integer, the second one is the character. I think almost most of it, all of it. Okay. This is the one that we look at Visual Studio, the last one. The last one. When using and trying to display proof of the first argument is the character, only the first character will be appears in the second argument. ARGB. Only the first character will be appear. We can have this kind of argument, line argument inside the main program. This is setting variable in the main program. These are called the command line argument. They are passed to the main function. It is passed to the main function. There are parameter or arguments applied to the program when it is invoked. When you execute the function, and they are used to control the program outside instead of the hard coding those values inside the code. Okay, ARGC, the first argument is always integer count, and the second was is always array of character pointer is separated by space. Actually, this is a file name. The name of the program. When you execute it, if you put if you want to display it, it will give you the name of the program. It points to the first command line argument. Okay, I think let me, if I can open this. I can what is it mean? Cannot show the okay, never mind. Actually, this is I mean, if you want to pass a common setting the variable in the main command line argument. We are not going to discuss it. Okay, this is just to show that even the main program also can receive the argument. Okay, can receive. By default, it has two arguments, and the first one is integer, and the second one. This is to, if I'm not mistaken, count register, argument for count register, and this is the name of the program. Okay, I have difficulty in running some situation. I'm not sure why, because maybe my laptop has a limited space, so there always be a problem. Okay. So we are going to discuss about array. What is array? Array is a data structure which you can store a fixed size location of element. And this element must be the same data type. Yes, because the array need to be declared first. Okay, to store a collection of data variable with the same type. This array also can be a static or dynamic. Okay, this part we are going later on. We are going to discuss into detail, and we can try to make a code of it. An array can be either one-dimensional, two-dimensional, three-dimensional, and so on. While in static array, the size is fixed. Okay, it's a fixed size. The size in the bracket is a constant and cannot be filled. Means that when you declare an array, it will be available and it cannot be, you cannot remove it. Okay, this is the example of an array, one-dimensional array. The name of the array, we call it variable A, and it has 224 location space. Okay, and when you declare this static array is going to be fixed, the system will save this location. 234. But we need to fix first the data type of this variable. What is it? Is it an integer or float or long? Okay, we need to fix it. Okay, the second one, variable B is a 2-dimensional array, and variable C is 3-dimensional array. Okay, what if we need the array that can be flipped or destroyed? Because this is going to be you require a huge location if you use the static array. Okay, because it will save throughout the running of the system. You cannot use that particular location for other purposes because you are fixed it. Okay, and due to the limitation on memory on the board, so we use the dynamic memory allocation. The other way is to use an array where you can create it and you can free it by using the dynamic memory allocation. Not only that, as a programmer, also we need to build a program that can accept variable size of input data, okay, where the variable size of input image, we don't fix it. It's not fixed, but when you run the system, you don't know yet. Okay, until when the user interact with the system, then you can we can know how big the size is. Okay, the user can specify from the command line argument, and our code need to be adapted using the dynamic memory allocation. Okay, this we are going to. Before we start with this array, we need to understand about the pointer and reference first. Okay, we are going to look in pointer and reference. Okay. Okay, pointer, reference, and dynamic memory allocation. Pointer, this is the most powerful features in the C and C++, where it actually allow the programmer to directly manipulate the memory. Okay. Which we know that in the embedded system is limited. If you use the pointer, reference, and dynamic memory allocation, it become more efficient. Pointer allow us to directly access the memory address and also can change their content. It can be good or bad. Okay. Later on, we are going to look why we mean good or bad. Okay, unreadable and unmaintainable codes, memory leaks, buffer overflow. Okay, this is some of the bit that of using the pointer also. Okay, and also easy to be exposed to hacking. Okay, it's also fun to learn about the pointer, reference, and the dynamic memory. Because these are all about the C and C++. If you understand this, I think you are capable to do everything about C and C++ somewhere. So that's why it is important for us to understand all these features, okay? Pointer, reference, and dynamic memory allocation. Okay, computer memory location, even in the embedded system too, it has address and holds a content. Okay, each of the memory has its address, and also it has the content. The content is up to the system, up to the programmer. Okay? But the address is always available. The address is always available. But the content is up to the system or to the programmer. How do you put the value? Or either the value is not being used, so whatever value inside the content is not valid. Okay, address numerical number normally being expressed in hexadecimal, while the content of modern CPU or even embedded platform use 8-bit. This is the common one. Each location, each address only contain 8-bit, 1 byte only. So in order to spare data types, for example, the integer required 4 location. 4 location, 4 bytes. So you require 4 location. We, as a programmer, actually we don't use addresses. We use variables, where this variable actually pointing to the address. So that's what is a pointer. We don't calculate the address. We use the variables. Okay, a variable is a name, location, address, which that can be store a value, the content of a particular type. For example, when we mention about integer test equal to 32, it means that this variable test is 32-bit size. Okay, integer is 4 byte. So 4 byte is 32-bit size, 4 multiplied by 8. As I mentioned, memory only 1 byte per location. So if you have 4 byte, so it means that you require 4 address of memory to put this 4 byte, which store 32-bit value. Okay. In this 4 location, the value is 32 in these examples. Okay. Okay, this figure might be clarified what we mean by pointer. Okay, this is the memory, and each memory is 8-bit. So, because we use the X number, so only 2 digits that we use. And this is the address. The address is 32-bit. Okay, this is your program. Okay, these examples, 832, this is the address. 8-bit for each of the location is 1 byte. Okay, this is a pointer that point to. It is the name of the variable is PTR sum. It is integer type. It point to the sum. So the value of this is the value. This is the value inside the memory. Is the address here sum. Okay, the address sum start at 90000. So because it is a pointer, so the content of it is the address of the sum. Since the sum is integer, so it requires 4 bytes. So for location, the PTR sum also need to be the same type of the integer pointer that point to these variables. Okay, how you declare it? By putting the star. We are going to look later on. Okay, short is a 2 byte, so it requires only 2 byte. This is the variable require 2 byte. Okay, you can have up to how many bit? 8, so 16 bit. Okay, and average is double, so it is 64 bit, 8 byte. So it requires 8 location to store the value here. Okay, class. Do you get it? Is there any question? Anyone? Any question? Do you get it?
Prof, so I just want to understand this slide again. So the computer, the address and content is in the left-hand side. The right-hand side is the name is basically just a program to group the content together.
Sorry, the program.
The,
The right-hand side here.
yes, the right-hand side, the right-hand side. So for example, the name of the programmer sum is to just group the program together. This content, the first 4 row of content together. So because there is 4 content, uh, it's equal to 4 bytes.
No. This is because this sum, this variable, is the integer type. Okay, as we looked before, where integer require 4 bytes. When you assign certain variable to integer,
Oh,
variable require 4, so it require 4. So for short type of variable, it require only 2. While average, we assign it as double. Double type of data require 8 bytes, so it require 8 location. Is it clear?
okay, yeah, it's better because I was confused with this. I didn't relate it back to the data types. It's okay. Thank you.
It depends on data type. So that's why you need to understand the data type. And this data type is referred to the location. Okay, it's 4 bytes, so you require 4 location inside the memory. Okay. Okay, so okay, how to declare? Here we declare a pointer variable. We call a pointer type. Okay, this is how you declare a pointer. Okay, if you look the first one, you can have type of data. For example, integer, double, you can put it here. And then you put star and the variable. PTR. Is the variable. Or you can put type. Okay, type is integer. Directly after the type data type, you put a star and then you put pointer. So this declare PTR also a pointer. Or you can have type and then you have space. You have star and then you put a variable pointer. So this one also we declare it as a pointer. This is the three type. All these type you can choose. But normally when you choose certain type of make it consistent, it's easier and it is more readable for other people to understand the program that you. I prefer the first one. Okay, you put integer, and then you put the variable pointer, star pointer. Okay, class, we break for 5 minutes. We continue after this 5 minutes break. The class, do you have any question? Excuse me. Okay. Okay, these are examples. Okay, you can write as this. You can declare IPTR as a pointer if you write the data type integer, and then IPTR. considered as a pointer. Okay, it is an integer type of pointer. And then we have integer star P1, comma P2. So in this case, P1 is a pointer, while P2 is just integer, variable integer variables. Or you can type double the data type, and then you have space, star, and then dptr, space dptr. So this also can consider as a pointer where it is a double data type. It is a double pointer, double data type. Usually we use P or PTR as a prefix or suffix. Okay, for example, IPTR, APTR, and so on, as a name, convention name. It doesn't matter, it's up to you, but to make it is readable, can be understood by others. Especially nowadays, most of the program is open source. So you want to make an open source, then people can continue improving the firmware. And it is better to use the name such as you. Okay, any question, guys? Okay, I'm going to stop here now because I think it's why, I mean, for me, from 3 o'clock, I need to give a talk. So for today, I think I stop here, stop a bit early. We continue next week. So before we end it, do you have any question?